Hello, everybody. Thanks for coming out. My name is Amy Cantu. I'm a librarian here at the Ann Arbor District Library, and I wanted to tell you before we bring Adrian up about a few related astronomy and astrophotography programs coming up. Next month on April 25th at the Downtown Library, we're going to stay open late, and we're going to have one of the members of the University Lowbrow Astronomers hook up his telescope to our large lobby, and we're going to show the moon live. It's called the Big Moon Live, so take a look out for that. If there are clouds, we're going to do it the next night. If there are clouds that night, we're going to do it the next night. If there are clouds that night, we're going to do it the next night. Unfortunately, that's how things work with astronomy programs. In May, Melissa Kalin, founder of the Michigan Aurora Chasers Group, which saw an increase of several thousand people after last week's wonderful Aurora show, is going to be here. She wrote a book called Below the 45th Parallel, The Beginner's Guide to Chasing the Aurora in the Great Lakes region, and she will be at the Westgate branch selling her book and talking about chasing the Aurora. And then real quickly, a couple other programs we have scheduled, dates to be determined, are a presentation by world-class photographer Jason Gunzel of thevastreaches.com, a presentation on Milky Way photography, and a meetup at a dark sky location for hands-on training, and a do-it-yourself workshop to make a barn door tracker. And Adrian will explain what a tracker is in just a few minutes. And now I'm going to introduce Adrian. Adrian Bradley is an amateur astronomer, a member of the local University Lowbrow Astronomers, the Royal Astronomical Society of Canada, and other area astronomy and photography clubs. He's been taking nightscapes since 2017 and has learned a lot since then. In particular, the importance of dark skies, where they are, how to find them, and what to expect in your photos when you're in them. Here to talk about his process and explain what the heck a Bortle zone is, please welcome Adrian Bradley.
All right, thank you for that wonderful introduction. As you heard, I'm Adrian Bradley, and the slide describes the affiliations that I have and the poetry, as you can see, written by Dr. David Levy. All of us call him David, a noted amateur astronomer, one of the discoverers of the comet that smashed into Jupiter in the 90s. It was him and the Shoemakers. But my talk, as it says, Chasing Dark Skies, and let's get into it with definition of what's a dark sky. So the slide, I won't necessarily read directly from the slide, but as the words say, there are many different definitions depending on where you have been and what you have seen. So, let's say visit because it's really dark. And then here's the definition of the Bortle scale. And I'm going to grab this. This is going to come in handy here soon. The Bortle scale, you said, used to determine the actual darkness of a sky. And we'll talk about how that does it. But if you don't have one of these, you can look at some things to determine how dark a sky is. Now, there are some things that people will tell you, and that includes seasoned astronomers. So some of the things that a seasoned astronomer will tell you in relation to a dark sky, such as the high altitude, low humidity, that's a useful piece of information. Milky Way creates a shadow might be a little vague. When you're somewhere where the Milky Way looking like that is bright enough to cast a shadow, it's something you never forget, because if you're not used to seeing the Milky Way that bright, and then you hold your hand up and you notice a faint shadow on the ground, it's something you'll never forget, and you'll equate that to darkness. I've had one of our astronomers, it was actually Charlie, he couldn't see his hands in front of his face when he was, I think he was at the Cherry Hill, I think it's called the star party out there. And then there are light pollution maps that show darknesses of different areas on the globe. Unfortunately for us, some of those maps are dated. They have 2015 data. And one thing that I'm finding is some of the data that I'm looking at isn't matching up with that 2015 data. So the picture that you're seeing is of a different region of the same Milky Way that's easier to see out there. The Okie-Tex Star Party, there are a lot of images featured here because so for me, it's the darkest place that I've been. And what you're seeing there is nearly a naked eye image. It's slightly processed, it's a little brighter, but when you're looking in that region as the Milky Way sets, you do see a lot of it. It's just not quite as bright. So the question put there, is there a way to give a fair assessment of how dark a site is? Let's suppose you see a picture of it. Can we look at the picture and say, okay, these features are there, therefore we know it really is a dark site, or I'm seeing things that conflict with what I think a dark site is. I think this was just an over-processed picture, and I'm not really sure how dark that place is. So here we've got 4 different locations. 3 of them are in Michigan, and the 4th is in Okie-Tex, or the Okie-Tex Star Party in Kenton, Oklahoma. So when we say the Okie-Tex Star Party, for those that haven't been there, it's in the Panhandle. It's out west. It's in the Panhandle of Oklahoma. And as you know, the Panhandle's bordered by Texas south, Colorado, a couple other states, Jim. What's New Mexico. So New Mexico, that's about a 50-mile spit, though. It's kind of far. Okay, so New Mexico, Texas, and I want to say to the north, Colorado, and there's one more state. Kansas is over there. So in this region, there's a lot of high mesas, and the overall elevation rises. The closer you are, or the higher you are up in the atmosphere, the thinner it is and the more transparent the sky. So the more that you'll see. And because there's not as much humidity as there is here, the darker the sky is. Now, none of the pictures here really indicates that as much. So let's see, the first one, let's go with the one on the upper right. That is Port Sanilac, and you're looking back at a combination of Port Huron and even some light pollution from Canada. And as you can see, there's a huge swath of light on the horizon, and where the Milky Way is rising is there's sort of a cutoff point to where you can start to see the center of the galaxy. If you drop below it, you've got a really well-defined dust lane, and you've got some darker clouds. Well, that's in the Upper Peninsula, I'd say about 30, 40 minutes away from Paradise, Michigan, which is where Tequamanon Falls is. And it's nice and dark there, and unfortunately I didn't have my Bortle scale reading to get an accurate reading of just how dark. Lake Hudson Dark Sky Preserve is, let's see, from here it's about an hour, I believe. It's in the south. There's a couple dark sky parks. TK Lawless is over here. Lake Hudson, and you can see the difference in how that region of the Milky Way looks from the Upper Peninsula to where it is in Lake Hudson. Same processing to produce both images. And that just shows, when there's less light from space coming through, the images aren't as bright. And then back in Kenton, Oklahoma, the reason I included this image is you have the Milky Way shining through really dark clouds. With no light pollution, if you see an image that uses clouds and the clouds are this dark, chances are it's a dark site because there's no light pollution for the clouds to catch. If you compare back with that image on the right, how bright these lower level clouds are compared to the sites where the clouds are dark, the clouds are a good giveaway that you're in a pretty dark site. So if you learn nothing else, the bottom line is if you look at images where clouds are included, the color of those clouds tells the story of how dark it really is, no matter how bright the Milky Way is presented. And now, so this is an SQM or SQML meter. And as I go through, I think I'll make sure, the Bortle scale. We'll describe what the Bortle scale is. It's a scale that basically determines darkness. It lets you know the higher the number, the brighter the sky is. The lower the number, the darker the site, the more starlight's coming through. So Bortle 0 is if you're kicked out into space. That would be as dark as it gets, is absolute space. Bortle 1 becomes any place on Earth that's the darkest place furthest away from civilization. And you can see everything through space. You do have Earth's atmosphere to deal with, but you may not have as much of Earth's atmosphere, especially if you're up at a higher level. So if you climb Mount Everest on a very clear, steady night, that sort of darkness. Bortle 2 is still, Bortle 2 is basically the edge of a truly dark site. If you have only been to like a dark sky park, say here in Michigan, and you go to a Bortle 2 site, and the Kenton, Oklahoma site borders Bortle 1 and Bortle 2. Very impressive. Some nights it may not be as impressive, but that comes with an experienced eye. And but for the most part, you will see things that in this zone would be a Bortle 4 zone. Bortle 3 is a little step down. You'll still consider Bortle 3 very dark. The appearance of the Milky Way to the naked eye can give the story of how dark a site is. The more of the Milky Way you see, the darker it is. In a Bortle 3 zone, you'll see the Milky Way naked eye look something like that, where it's fading into the sky and you'll see some structure, but it'll be faint. This image is taken in a Bortle 4 zone. If you're there naked eye, it looks like the White River. You see some structure, but like the color, the dust lane structure doesn't show up as much. And then from there, Bortle 5, 6, and 7, where you're in a rural area near a well-lit city, you're in an urban area, and Bortle 7 and on up, you're sitting in the middle of Michigan Stadium during a game. So that's how the Bortle scale works. It's an indicator of how dark a place is. Now, this meter will calculate a number, and it'll put a number between 16 and 21, and the simple answer is the higher the number, the darker the site. When you get to a number like 21.99 or 22, you're at Bortle 1. And then higher than that, you're climbing in altitude and you're heading to space. Lower than that, you're in one of the other zones. And what you're gonna see as I go through some of the places and show some of the pictures that I have, you're gonna see numbers, and they'll correlate to the pictures that are there, and they'll correlate to a particular Bortle zone. So most of these are taken in Michigan. I do have a few from Okie-Tex. So here we have, and mostly you're going to find in Michigan, even if you're along the lake or you're further north, you're going to find that those sit in a Bortle 4 zone, which is still pretty impressive if you notice the pictures. Notice the faintness on the far right. That's a picture where Orion is just off of the screen to the lower right. These are a couple of different regions of the Milky Way, and they're all being shot over Lake Huron. The region in the middle is the second brightest region we can see in the Northern Hemisphere. The region on the left is the galactic bulge that goes to the north. It's in one of the brightest regions. And so this is actually typical darkness of most of the dark sky preserves in the lower peninsula of Michigan. Still impressive enough to do visual astronomy. You can get some nice images of the Milky Way here, but as you'll see compared to some of the other sites, you can get to some darker sites. This is Alcona County, and you see there's a little more detail. Now, the image on the right is actually a stacked image, so there isn't much indication of how dark it is except for the sky color, something I forgot to mention earlier. If the imager leaves the sky color in his images as the way that he sees it, the darker metallic, there's a dark metallic blue that you're seeing in the right image. All of these are from the same location. Basically, there's a bridge in Alcona County, and the sky has a blue metallic color when the numbers read 21.2, and even at 21.4, which you'll see a slide with that later, it starts to head towards a grayish look. There's Milky Way imagers that believe that this bluish metallic blue is the proper way to render the sky, but if you are careful at doing your imaging, and we'll talk a little bit about that before we do the final slideshow. You can get the sky color, and the sky color, the brighter and lighter blue the sky color, the less dark a site is. And so this is another part of the Thumb of Michigan. It's a very similar location. Some of the glow would be sky glow, but then we're talking the tip of Michigan, and we're still at 21.2. This location in 2015, the numbers were more like 21.6, 21.7, and it's down to 21.2. You can still get some impressive shots of different parts of the Milky Way, but it does take some processing. These are places where distant aurora will show up. And same story, there's the distant aurora sitting on the right. Now, this wasn't from this recent aurora display. What I've heard is that if I were to stand there the other night, the aurora would have climbed higher in the sky from here. It would have covered the height of the tower. So that is impressive. This was impressive too. It was in 2021, and I got lucky that I was there during the when the solar activity just took off during the spring equinox in March of 2021, and ended up getting to see, and it's harder to see naked eye, but I could see the movement. I could barely see the color, and when I put the camera to it, all of the colors showed up. And so this is the same area, different parts of the Milky Way. They look pretty bright. The image on the left, if we pay attention to that image, that's Orion rising. To the left of the plane of the Milky Way, we're seeing some elements of sky glow. And I'll try and define sky glow. It's not quite aurora, but aurora-like. It's there's light that, there's green and red light. It's basically stored up energy from the sun during the day that then glows, radiation at night. And depending on whatever element the glow that you get depends on the element that's been absorbing radiation from the sun, and it shows up as sky glow or air glow. It's got, I think air glow is a more common term. We'll use sky glow sometimes for light pollution, but either way. So that shows up. The darker the sites, the more of that sky glow you'll see. Yep, come on in. And so one thing that I'm looking to do with my meter, go back to some of these sites and get some more readings. This is the same location, but look at the max reading I got, 21.4. So on that particular night, and I think that was 2 nights before the aurora hit, I went out. The glow that you see in one of those images at the bottom is actually glow from a town. That's not aurora. But yeah, it was, this was very recently, and it was 21.42. So that number means 2/10 on this number correlates to slightly darker, better transparency. When I looked at the dark sky charts, transparency and seeing were both average. And actually, I think seeing was listed as below average on this night, but the total darkness registered higher than it did the last time I came to this park. So on any given night, the numbers can fluctuate. And so what I do is I use my meter to get an average, and then I go back out, get another average, and start adding it to what I've already got, and get an overall sense of how dark a place is. This is Point O'Bark Lighthouse Park, and it is in Port Hope, Michigan. It's a really nice place to visit during the day. They've been making some changes. And at night, it's got, even though the lighthouse is there and a couple of other lights, it's got a pretty reasonably dark sky for the state of Michigan. And missing are my Upper Peninsula. There are some Upper Peninsula shots that I have that'll show up in my slideshow later that will be added when I get a chance to go back to the UP and take some shots and take some readings. I'll be adding the Upper Peninsula. My guess is the numbers will be 21.6, 21.7, which puts it in a Bortle 3 zone. It should be Bortle 2 there, but again, we'll have to see. The numbers have been going down due to the sprawl of light that has been going on even in the upper part of the Lower Peninsula, and maybe even creeping into the Upper Peninsula. We'll find out. But these are the readings we get when you get into Kenton, Oklahoma. Now, if you notice how that region where Orion is rising turned out compared to how it turns out over here, notice the big difference. How much more data. We call it data in the astrophotography world. It's how much brighter that region looks when and then you can see the air glow, the greenish air glow underneath it over here. You can still see some of the reddish and the green. It isn't as pronounced. The clearer and more transparent a sky, the more astronomical phenomena you see. Look how bright that galactic center looks. And then that's the zodiacal light with Orion rising. I do have a camera that gets some of the spectrum of light that we can't see naked eye, and then it assigns it a color. So you're seeing like Orion with some of the hydrogen alpha that exists in that region. But most of this was naked eye visible. Some of the detail and the brightness, when you put a camera to it, you get more data. but a lot of this was naked eye visible. Fainter with your own eyes, but visible. Over here, wasn't visible at all. A lot of what you're seeing there isn't visible at all. And the aurora, even the aurora colors were not as visible, but you could see spikes in the distance. You could see things like that over in Oklahoma. If there's aurora in Oklahoma, then it is a huge storm. Word has it that this last storm, people in Florida were seeing aurora on the horizon. So it was a pretty good one. But look at the SQM readings. And if you look on the meter, none of you can see this, but it goes to 21, and the scale shows full moon type light at 16. And then when you get to 21, there's lots of stars. It's their way of basically saying the higher that reading, the more stars you can see naked eye, the more you can see in the night sky naked eye. My horizon, I often point at the horizon to get kind of a full picture of what's going on. And when it's 21.8 at the horizon, it's, that's darker than the zenith and all of the places in Michigan that I showed. So here we're near let me see what time we've got. Yeah, so we're near the end of the slide. These are other images. There's more aurora I couldn't see from the Upper Peninsula. These are other images I've taken from various sites, and that upper right is me reenacting the time I went out to look at the Milky Way naked eye years ago from a spot that's not far from here in Ann Arbor. And I don't have a Bortle reading, but I'd be interested to find out. And also pictured, the middle image is our observatory at Peach Mountain, and it gets decently dark there. And pictured to the left of that, notice that it's kind of a similar look to that Milky Way. There's another image looking over at the light pollution, the brightness where Port Huron is, and then more light pollution to the left of that, where I suspect that's where some Canadian towns are in the distance, and that's Lake Huron. And that's the Milky Way rising. And I think this is going to be the last slide, and talks about my ultimate goal to get more data, and not just to take pretty pictures, but to take these readings, upload them to sites that are taking that data to recalculate how dark places on the globe really are, and bring awareness to the fact that in a lot of places that used to be darker are not so dark anymore. And so it all goes into showing how fast we may be losing our night sky. And so I wanted my images to be a part of that, because rather than just take pretty pictures, enhance the Milky Way and put it online and see how many likes I get, I thought it was more useful to take pictures that actually tell the story of what's going on in the sky. This image is a good one because, with the exception of the reddish color in the Lagoon Nebula, that is essentially what you see naked eye when you're staring up at the sky in Kenton, Oklahoma at the Okie-Tex Star Party. That I tried to make that as exact as I could. There'll be a little bit there, like for those that know astronomy, there are a couple other nebula there, M17 and M16, that show up as pinkish spots there. There are some star clusters there, but that bright star cluster, you can see that naked eye when you're there, and you can see some of the other bright star clusters. So that's essentially the when it's dark enough, that is how much you can see visually. And so with that, I'm gonna go ahead and talk about some of the trackers, how I get, this is gonna work. How I get some of the images, I use a fairly simple setup. And this is my setup. Amy's is over there, I'll grab it. And I'll give you some props, Amy, because you've used this to grab some pretty amazing astro images. You focused on some deep sky objects with just this, her camera with a large lens, kind of like this, but then a larger lens. The tracker follows the Earth's rotation. And as the Earth rotates, the sky, since we're standing on the Earth, it just appears that the sky is moving. It moves at a slow rate, and these trackers follow that rate. So if you didn't have it and you took a long exposure, you get smearing of the, you end up getting smearing of the stars and everything else. In order to, either you have to take shorter exposures, which means like 20 seconds for my 16 millimeters here, I can shoot for 20 seconds. I can shoot as wide open. For those that know photography, you shoot for 20 seconds, you shoot as wide open as your lens will, so your f-stop number, aperture, as wide open as it can get, and your ISO setting, depending on how much of the image you want to see, most of the time between 1600, 3200, gives you a pleasing enough picture of the night sky. And that's without a tracker. But when you want some of the images, like the 2-minute image in the middle, and I think all of these are 2-minute images, and you want to pull more data out, you're going to need something like this to track the night sky. And with this process, I used a composite where I took the same amount of time without tracking to get the foreground, and then tracking to get it to follow the sky, 2 minutes each, and then go into a program like Photoshop to layer the two together, merge those images, and then treat it like a single image. And then when you do that, you end up with a reasonably sharp foreground and a reasonably sharp sky. So from there, a lot of imagers will sometimes take their foregrounds during dusk or during a different time. They'll come back, take the sky photo, and then do the composite. Sometimes they'll make the Milky Way image larger than life and put the two together, and you have kind of an out of balance picture. But you know, that's where it gets to be each other's art. We mentioned that Jason Gwenzel is coming to talk about his astrophotography, and he does a great job of not only Milky Way photos, he also does deep sky as well, and he uses a full telescope. To do this sort of imaging, you don't necessarily need a telescope or like a telescope tracker. You can use a small tracker like this, which is called the Move, Shoot, Move. This is a wedge that you have to put it on, and you put it on a regular photographic tripod, and you use this sort of thing, an intervalometer, so that you can take a set exposure. I do this all the time. So you use the intervalometer to control how long the exposure will go. Now I have a backup wired one in case something goes wrong or I run out of battery with this. I can use a wired controller in order to use bulb mode and then just time it. The idea is you don't want to be bound by 30 seconds, which is the longest exposure you can take on camera. Most cameras, this one is modified and it'll take light from a spectrum that we can't see in the red spectrum. This does the same thing. It has similar, it's got all of these modes here to do similar things to this, but it also, it comes with the port that you can plug your camera into, and it can handle the exposure time. This one has it. I haven't used it. I've just been better off using my own intervalometer. But things like these, and notice it's the same. I had one, but it broke, so I used the wedge for my move, shoot, move. These sort of things can cost $200 to $300 unless you're lucky enough to win one at a star party. And you add them if you want to do night photography where you're doing longer exposures, or if you want to use it to do time lapse, it's got that option. But for what I do, it's mostly night sky photography. So I think we're doing pretty good on time. I'm going to go ahead and run a slideshow of images that I've taken, and what you'll see in the images is I've taken enough shots for some years that I now have tracking of Orion as it's setting, which is kind of like now, you know, the end of winter, beginning of spring, the rising of the core of the Milky Way that we can see here in the northern hemisphere, how it stands on end, rolls toward the west, and then as it's setting, we go from summer when it's standing up to fall and back to winter as the last vestiges of summer set and Orion returns, and you'll see Orion coming back up in the sky. We put it to music, and it's about 2.5 minutes. Hopefully you'll enjoy it. Where I find it. Oh, there you go. So that play one. All right. So here is, yep. So here's my latest slideshow, the progression of the Milky Way from the northern hemisphere. Before I hit play, there are 2 areas of the Milky Way you won't see that are in the southern hemisphere that I hope to gather at some point. One of them is where the Magellanic Clouds are, and the other is where Southern Cross and Eta Carinae. When you see Orion standing up in the sky, you're going, if you could imagine going equidistant below the horizon where the Magellanic Clouds are. When you see the core standing about equidistant, that is Eta Carinae, Southern Cross, Jason Gonzalez imaged it all the way up to, I think, Mauna Kea in Hawaii, and caught the rise of the Milky Way on both sides of it. So those are the only 2 regions you won't see. There's a region where Andromeda, the Andromeda Galaxy shows up. I think there's one shot with that in there. Without that, let's go ahead and play. And after that, question and answer. shot. David Lee, one of the first shots I took, David saw it, he said he loved it. Process. One of the many reasons that I continue to do this sort of night sky photography, well, maybe a fascination, Milky Way, observing it, seeing it change over the years. It's something I really enjoy to do. It's something that gave me a purpose when it comes to astronomy, what I like to share with other people, my love for the night sky. It's something that David had, and he's passed it on to me pretty well. And so have those of you who have been with the lowbrows, you've seen progression. And so that is that's where all of the passion to drive out to all these places and take pictures of it. That's where a lot of that comes from. So with that, we'll open the floor to questions and answers. If there are any questions, thank you.
If you have a question, I have a phone here.
Could you tell us what type of camera and model that is? I know, I think it's a camera, and is that CCD or CMOS?
I believe it's CMOS. It's an old Canon 6D. I think these are CMOS sensors in here. It's a modified Canon 6D, which means there are two filters that filter light and give images the appearance. Basically, it's like what our eyes can see. And when you pull one of those filters off, the sensor then processes that light, and some of the regions you see around Orion that are pinkish start showing up in your images. So you see more of what's actually in space when you have your camera modified. Some cameras you can buy that are already modified to do the work, so you don't have to send it. I think there's an RA mirrorless that is out there that you can get that does the same thing that my 6D now does.
While you're on that, Adrian, what is a good first lens for somebody who's interested in starting Milky Way photography?
So Milky Way photography, go for a wide angle lens like this. Well, if you get something, anything between 14 millimeter, 15, 16, 17, there are cheaper options than native Canon that'll fit, depending on what your camera is. Nikon, or if you have Sony, a wide angle lens is what I recommend going with. And you know, again, by wide angle, anything that can widen out to, I would say at least 24 millimeter is fine. The kit lens 18 to 50, I believe, that came with most of the older Canon lenses is a good start. Once you get into it, you find that the wider your aperture, the better. This is an f2.8 lens. There are some lenses that go down to f1.8 and even f1.4. Some of those lenses, it takes less time to try and grab an image. So yeah, start with something wide angle and work from there.
Are those the best cameras to use, or are there better ones out there?
Full frame is about the only thing I would say is better. The Canon 6D in particular seem to work well in low lighting. There are other camera models that are purported to work better in low lighting, such as the Sony A7 III. I'm not sure which one for Nikon, but I've seen some really good Nikon produced images. Full frame is about the only thing that I would recommend looking into, because the bigger your sensor, the more light it can take in. You don't have the sun to help you, you only have all this starlight. So you use the largest sensor you can, which affordable, if you want to go with affordable, a full frame lens is the best way to go to get more of the starlight that's out there. Well, go ahead. You go ahead, and then I'll talk to you. I'll get your question.
I am somewhat familiar with the headlands up at the tip of Mackinac.
Yes.
What's the Bartle reading up there?
I plan to go there. I can tell you that the Bortle reading is likely 4. And you've been there, you know how dark it is. When I get an actual reading, I'm expecting to see 21.2 or 21.1 at worst and 21.4, very similar to what I saw at Point O'Bark Lighthouse Park. So I'm expecting that. And actually, if you go across the bridge, the Mackinac Bridge, and you go for about an hour, those skies are even darker than the headlands.
I was up there maybe 4 years ago, during the races,
Oh, at that time, I'm sure.
it was really,
Yeah, so the numbers there were probably much better than they would be now. But that is one of the places I intend to go and actually measure. So that's the only way we really know. And if I pick a really good night, that'll be even better. So now go ahead.
how low do you think is like Joshua Tree National Park or more?
Where is it located?
Like Zion, California and Utah?
In that area, you're no higher likely than Bortle 3. You're probably sitting in Bortle 2, and there's probably some areas, some small areas that hit Bortle 1.
Anybody else?
I have a very amateur newbie questions.
No problem.
There's lots of these drone things going on. I mean, is it, how far up is the light pollution? I know
So-
it's not going to help us, but your camera,
Well, what happens is you see streaks going through some of the images, but it doesn't necessarily block the entire image. When you're doing wide angle photography, not only do streaks get in your image from satellites, planes are even more prevalent, and the occasional meteor gets caught in your shot too. You saw one of those back there where there was a meteor. So it's a known issue, but it hasn't interrupted being able to get night sky shots. Some of them, like depending on when they are in the sky and when they would be visible. I believe Starlink, for instance, is like early evening and then early morning if they're orbiting where I'm doing imaging. So for the rest of that time, you just have other things to contend with.
one other question was going back to what you were trying to attempt by cataloging all these places and what the Bortle readings were. Is there a way to get a lot of data all in one shot by looking at it from above rather than you going to every place and
Well, there's a
dark sky?
there's a site online called I think it's Dark Sky Finder. Clear. Yeah, there's a light pollution map. Let's show it on the screen. Gonna answer your question. Somewhere in here, like you said, Jim, there should be a link. Dark sky map. For some reason, I'm not seeing it, but I. Okay, now this is showing forecast. Light pollution. Oh, right here. Light pollution. There we go. Okay. So this is the view. Oops. Yeah, this is that view from space, if you will. And the map. What the map is showing is the brighter red. That's where light pollution is greatest. And then we go into green and then blue, dark blue, and gray. And when you get to gray, that's where the sky is the clearest. I'm gonna see, because I think there's also, if I go dark. Yeah, here's the light pollution map right here. Yeah, so there's the light. So this is a point, and Jim, you tend to illustrate this very well. There's the United States, and there's the light pollution map. And what you notice is right around where the Mississippi is, there's a line where on the east you have lots of color, and to the west you don't. And that's why states in the west see a different sky than we do. There's less civilization, therefore less light pollution in the west. Then you get to California and it starts to brighten up again. But that area, and when we talk where Kenton, Oklahoma is, we go down in here and we look for it. I thought I had it. Oh, Blacklit right there. Yeah. This is the area where we go for the star party, and notice dark gray. So which is why we go. Now let's go over to Michigan, if I can control it a little better. Okay, this was working. Okay. And notice how southern part of the lower peninsula is brighter, but there's less of these reds and yellows when you go into the northern part. Some of the spots that I image from are here. Point O'Bark Lighthouse Park is this little notch right here. And along the Osable River, Glenny, the Alcona Campground is this area here. What about the, whoops. And then what about the Upper Peninsula? Well, so there's the headlands, right? I think the headlands are up in here. This is another spot. Headlands are in here. And you go across the bridge, and over here where Paradise is, that's also pretty dark. So some of those regions, however, this is indicating that, you know, they're in a Bortle 2 zone. Over here, you've got, it's pretty dark. Bortle 3 is indicated by this color, and then Bortle 2, this gets into Bortle 2. Well, I've gone to those spots, I've used the meter, and the numbers have not matched up to that. It's shown Bortle 4 or high Bortle 4. So this map, I feel the map's a little outdated and needs to be updated, but it still tells the story.
Hey, while you're right there, Adrian,
Yeah,
what is the big red spot up there in the UP? Just over the bridge, is that Sault Ste. Marie?
I believe so.
I'm just going there tomorrow night, and so.
Yeah.
Just wonder if it'd be worth looking at the sky.
Well, if you go to the outskirts of it, it'll be worth looking at the sky. Yeah, there's a town here, and then there's Sault Ste. Marie. If you click on that,
You're right there.
yeah. Yep, you can see the words. Yep, Sault Ste. Marie. So, yep.
Thanks for spoiling my weekend.
No, just go 30 minutes. You see how it looks kind of like a mountain range. You get out of the main city. As soon as you get here in the green area, it's going to start looking a little bit better. Then you get into here, and then here, and then you're heading to Paradise, Michigan, and it's going to get really good. So if you're willing to take a little trip outside of Sault Ste. Marie start heading west or north and west, you will see some of those skies that you hope to see in Sault Ste. Marie.
Go to Prairie Springs State Park. Isn't that a dark area?
It is. That's one place I haven't been, but a few of the lowbrows here have, and they can.
How would that look on this map, though?
Where would that?
In Pennsylvania.
Okay, so go to Pennsylvania. Should be a way to hit Cherry Springs. Where is this? Or here's the
Just
search
enlarge
right
it.
here. Type that and then type Cherry Springs. And as you heard from that might be, because this is the Pennsylvania. Let's see what this says. That might be the. Yep, that's it. Yeah, so some of the places like Cherry Springs is a fairly well-known Star Party and Dark Sky Park. So yeah, it's already listed. And yeah, you see why. Look at these colors. Dark, dark blue. So like Jim just said, it's dark. It's the type of sky you get here on the best night. This is a little bit darker. I think this is going into, at the time of this, it's showing somewhere between Bortle 3 and Bortle 2. And the Bortle zone is not an exact zone. Once you're at Bortle 3, you're in a range. So the lower end of it won't be as dark as the upper end. So you might still be in a Bortle 4 zone, but there's a difference between low Bortle 4, which is Lake Hudson Dark Sky Preserve, where there's a lot, you can see the light pollution creeping in the, on the horizon from different towns, versus high Bortle 4, which is, these areas up here in the Thumb and up here around Alcona and in this area, and even the Sleeping Bear Dunes National Lakeshore, which probably gets a similar darkness on its best night to Cherry Springs. So back to the answer, it's dark. Now, compare the way the sky looks at Cherry Springs to this. It's different. There's a grayish tone to it. In fact, if the slideshow is still here, okay, that's that slideshow. Where is my presentation? I think I must have exited out of it. Yeah, I think I exited out of my presentation, but yeah, I don't see it. But oh, it's right here. Okay. So really quickly, all of these guys are in Michigan, and you see that metallic blue shade. But when it's dark blue and there's a grayish hue there, and then you've got some of the sky glow. The sky color to the eyes appears more grayish in the west, in this region, in that region where it's you've got higher elevation out there, less humidity, and less civilization to cast light into the sky. So the darkness of the sky is a factor of all of those. It's more transparent, and there's more to see. So when looking at it through a telescope, you see more of whatever object that you're trying to look at through the telescope. The moon, of course, being kind of an exception, it's really bright. So if you're looking at galaxies, you're looking at detail with your naked eye through the telescope, like spiral arms and things like that. Yep.
So if you're planning to take a picture of the Milky Way, do you have to focus the camera,
Yes.
or?
Yes. That's a must. And two things you can do, or the most important thing to do. I use manual focus, and if I'm not sure where the focus point is, I find it, and then I look at where that was. I either make a mark, take down where that was on the camera where I got focused, and then when I come back out, pull out my headband or whatever. I try to do it away from the visual observers, or the fire hose will come at me and it'll hit me like this. But set it right to where it was in focus before, and then I can start imaging without worrying about, am I in focus? I can tweak it a little bit using live view in the back of the camera, but get back just to the answer to the question is yes, focus is important.
You mean focus during the day and then?
You can
Figure out
focus
where
at
the-
night. If you focus at night, and there are a couple of ways to do it. If there are planets in the sky, use the planets to get a good focus. The stars will come when you use the planets. If you use the moon, the stars are just so slightly off.
Were there any other questions?
We have one.
Light paint in the foreground other than natural light?
I don't often light paint the foregrounds. In one of the pictures I had at Point O'Bark Lighthouse, there was light already there. I let that do the light painting for me. I pull that in. So any light painting that happens is incidental. It is, but there's actually grades of infinity, and you can be out of focus. You could be you can have it directly on the infinity number and be out of focus.
All right, well, thank you so much.
We had one
Adrian.
more from Jim.
One more question?
People were asking about church. No park like it. As far as our field. Any dark of the road, especially in local weather, there'll be a couple hundred people observing and photographing. And they pretty much self-police and they deal with on-site light pollution. People opening their car doors and turning on lights, such like that. It is powerful. So if you really want to go to a dark sky, yeah, it's 400 miles.
Yeah.
The other thing on the mortal scale, if you know the night sky at all, you can take sections of various constellations and count the stars in, and that number of stars you count corresponds to how dark it is. How dim a star you
Yep. I will caution though, make sure you do your scale according to your vision. If your vision starts to go, you'll see a little less than say I might see. I might see more stars in the same zone in the Little Dipper than you might, but that scale slides. You go somewhere where it's darker and you see more stars, the way Jim was describing it. You start with that scale Jim was talking about and say these are all the stars you can see in a particular Bortle zone, and then you go from there. So that's one I should add to my presentation, Jim, the number of stars in particular constellations.
Okay, well, thank you so much, Adrian.
Thank you for having me.
I thought I am going to see